State configurations are data items detailing how a component interfaces with the flight sim. The data items are events and variables, or if using X-plane, commands and data refs. A state configuration exists for each state of the component, and all these configurations together make up a set of state configurations. Events and commands do something in the flight sim, for example turning on the autopilot. Variables and data refs provide information about what is happening in the flight sim. For example, the state of the autopilot, is it on or off? State configurations can be assigned directly to a component on a module in device panel mode. State configurations can also be built as a snippet. A snippet is a special sort of state configurations. They are pre-built and also have component label information. A snippet can be picked from a list of available snippets, and assigned to the component without having to understand any of the data items contained within it. See the tutorial on building snippets for more information. This tutorial will show how to build state configurations for a push-button, LED, rotary, and a display. State configurations are built for the current aircraft loaded in the flight sim. A snippet can be built as a default snippet, which can be used by all aircraft, but overridden for specific aircraft when required. We therefore recommend the use of default snippets, and only build state configurations directly on components if you really want or need to. The first thing to do is look at the aircraft name. These tend to be very specific for the loaded aircraft and its livery. So the simple act of using a plane with a different livery often results in the state configurations not being available, because the aircraft names are different. Therefore, before building any state configurations or aircraft-specific snippets, you need to shorten the aircraft's name so the software can correctly match against all relevant aircraft. To shorten an aircraft's name, make sure the aircraft is loaded, and switch to the Flight Sim IO server. On the Settings tab, in the Aircraft section, you can see the current name of the aircraft. In our example, it's the Beech Baron 58, which is a reasonable name to start with, as it has no livery names or other information attached to it. This is often not the case. However, we may want the state configurations to work with all aircraft that start with Beech Baron to broaden its usefulness. To do this, we will remove the 58 part of the name, and click the Save Name button. If we go back into the virtual hardware builder, we can confirm the name has changed and that any state configurations we build will be associated with this shortened name. Note that the aircraft name can only be shortened when the virtual hardware builder is running. We will now configure a push button. State configurations are built in config mode. Once in this mode, select a component to configure. You can now see at the bottom of the screen the state configuration area. We can switch between each state configuration for the selected component via the state combo box. A push button has two states, released and pressed. Unlike a switch, where all its states can be usefully configured, a push button is best configured on its pressed state to give a more immediate impact in the flight sim. Notice how the data items are now disabled. On most component types, data can only be configured on state 0, but it will be applied across all states. You may also be wondering why data is available at all for a push button. It is present because the push button and the LED are linked, and therefore can share a single set of state configurations. The LED would use the data configuration, and the push button would use the event configuration. Clicking in the event combo box allows us to search. We have assigned the anti-ice toggle event to the push button. Toggle events are perfect for push buttons, as they toggle between the flight sim functions. In our example, anti-ice functions will toggle between on and off each time the push button is pressed. We don't need to do anything else for this push button, so we will move on to the LED. The LED has two states, but only state 0 can be configured for data. Again, event data is available because the LED is linked to a push button. It would not be present for the LED if it was not linked. Clicking into the data combo box allows us to search. We have assigned the panel anti-ice switch variable to the LED. This variable has the value of 0 when the anti-ice switch is off, and a value of 1 when it's on. Normally we would assign a data action to indicate what needs to be done with the variable. Because the LED should turn on, which is state 1, when the anti-ice switch is on, we would set the data action to be on, and enter 1 in custom value. So then, whenever the panel anti-ice switch variable had a value of 1, the LED would switch to state 1. It's on state, and light up. However, this particular LED component has a lit method assigned to it at the component level. The lit method assigned is data-driven. The data-driven lit method will automatically switch the LED between its states based on the value of the variable assigned to it. When the variable is 0, the off state is shown. When the variable is 1, the on state is shown. The use of this lit method on the LED means we do not need to do anything else for it to work correctly. We will now configure a rotary. In our example, the rotary has two states, clockwise and anti-clockwise. Rotaries can be built with extra states, where they act as push buttons as well as rotaries. Clicking in the event combo box allows us to search. We have assigned the heading bug increment event to the rotary, which will increase the heading bug whenever the rotary rotates in a clockwise direction. We can now add the opposite event for the anti-clockwise direction. We don't need to do anything else to configure the rotary, so we will move on to a display. For this tutorial, we have temporarily removed the snippet assigned to the COM1 radio display. This display only has one state, however some displays can be built to have multiple states, allowing different data to be displayed as the display is cycled. The display clearly needs to show the current COM radio frequency, so we will search for it and assign it. Nothing else needs to be configured on the display. Although building state configurations and snippets can appear daunting, it really can be a very simple process. Much of the additional functionality is for advanced usage, which many users will not need. This concludes our tutorial. I hope you found it useful.